we need to find the next step is find the first and follow set of symbols. Usually, first set of symbols will go is the first terminal on the RHS of the production, and if we have only non-terminals, we'll apply the rule number 3. If A produces XYZ, then first of A will be equal to first of X, and if X is producing epsilon, then we should go for the next one. That first rules and all we have practiced many times in the class also. Fine. Now see, non-terminal is S. S is producing open parenthesis, L close parenthesis, and S is producing X. It is very easy to find the first of S. It is open parenthesis and X. Fine. Next production is L. L is producing S and L is producing L comma S. So for that reason, first of L is equal to first of S. And again, we're going to get first of L is equal to first of L. That doesn't make any difference. So for that reason, first of L is equal to first of S. We already have first of S. So that is open parenthesis and X. So the first of L will also be open parenthesis and X. As simple way we have calculated the first set of symbols, right? So we have taken many complicated examples and also have computed the first and follow, right? This should be a simple task for you people to calculate the first set of symbols. Okay, then next is a follow set of symbols. We shall see that same thing. This is a follow set of symbols. S, as S is the start state. Sorry, here it's supposed to be okay. What the idea? As S is the start state, follow of S is equal to dollar, because this is the first rule of our finding the follow, wherein if it is a start state, the follow of the start state should include dollar, right? So, and then we are applying the rule number 2. If there is a production of the form, A produces alpha, B, beta. Yes, we have the production of that form. The opening parenthesis is your alpha, the L is your B, and closing parenthesis is your beta. We should include the first of beta in follow of B, follow of B. So for that reason, follow of L is equal to first of closing parenthesis. First of closing parenthesis is closing parenthesis itself, because we know that first of a terminal is itself, right? And we need to check again, is beta producing epsilon? No chance, beta is not producing epsilon. So we need to go for the next one, right? Oh, sorry. If this should be done, if the beta is producing epsilon, then anyway, this step is not there. Please ignore this. Next production is S produces X, and we cannot. There is only terminal on RHS, so we cannot compute the what do you call follow. So the next production is L. L produces S. So this is of the form A produces alpha B, but alpha doesn't exist, but B exists on the RHS. So we need to include follow of A in follow of B, right? Follow of A in follow of B. So for that reason, follow of L is equal to follow of S. Correct? No, it should be in the reverse order, right? Follow of S is equal to follow of S is equal to follow of L, right? Okay, and that then we got the dollar in that, right? One second, I'll also remove this. Anyway, this one is not supposed to be done, and this step should also be removed, right? Okay, right. Right. Okay. Follow of S is equal to follow of L, right? Follow of L is having right now closing parenthesis. This also supposed to be changed. This we got closing parenthesis, right? Okay. It was very difficult task to do all these animations, and so that's why a few things has gone wrong. Please consider that. Yeah. And yeah, next is L is having the second production. L produces L comma S. So two non-terminal symbols on RHS, L as well as S, and there is a comma. Fine. So first step we need to, this is of the form A produces alpha B beta. We are making the L as B first and then we're going to make S as B. Right. So because of that reason, we should include the first of comma, that is first of beta, alpha B beta, first of beta, that is your comma in fall of L. So for that reason, we got fall of L is equal to first of comma, that is comma itself. Correct. Next is uh, so this again is a wrong step. This step will not be there. We should, yeah, there is some mistake which I have did while computing the first and follow. You can compute the first and follow, but have a look at this table. This is manually computed one which I have computed and I have put here. The first of S will going to be open parenthesis and X. First of L will also be open parenthesis and X. Follow of S is dollar closing parenthesis comma and follow of L will going to be closing parenthesis and comma. This manually you solve it. It is highly difficult task to demonstrate that on the what do you call slides, because manually it would have been easily solved, right? Fine. So this is the step, second step. Step one is we should we should augment the start state. Second step is we should find the first and follow set of symbols. So we will get this table and this table, and the next thing what we get it LR of the item set. These two together will going to form our what you call parse table, and then we can go for the parsing. Yeah. Now SLR parsing table construction, for doing that, based on the key idea that handle should be reduced. This is what is the overall idea in the SLR parse table. What is that? Handle should be reduced to a non-terminal, means we are going in a bottom up way. We should take a handle and reduce it to a non-terminal if there is no more tokens left out in the production. Now, suppose if I have X produces A, small b, and a C, but I have A and B but not C, then it is not a reduction. We cannot go for a reduction. This is one thing. Second thing is that I have an X producing A. A is a non-terminal. And if that A is non-terminal, is having other production, then we should have seen the productions of A, then we should come to the rest of the productions of X. So these are the idea. When we implement the parser, you can easily understand this. Yeah, fine. So for that reason, we use this notation. Reduction of an item is written like this. N produces alpha dot is done only if the look ahead token is part of your follow of. Then only we get, means we should have seen all the follow set of symbols before we reach the reduction. Okay. In order to achieve this, we use something called dotted item set. This is actually the important thing about what is needed. We call it as dotted item or item set or items. This simple, right? This is a similar means. This is similar to our DFA. Have a look at this. Dotted items, also known as items, a concept used to summarize the state of our search and sets of items to represent the sets of hypotheses. This is all. This is the thing. Observe this. Observe the example. Consider a production n produces alpha beta. Then this dot at the beginning will be there at the beginning of alpha will be moved to or between alpha and beta after we have consumed or after your parser has recognized the symbol alpha. That means if symbol is a terminal, then only alpha. If alpha is a non-terminal, then all productions of alpha means should have been parsed alpha. Alpha beta is a possible handle. We have already seen alpha. That then only we can move the dot next. And when we can replace alpha beta by n, when this dot has reached the extreme end, then only we are able to replace alpha beta by n. So why this is leading to a bit of confusion is that because there are two possible alpha and beta can be terminals. Then it is just consume alpha, move the dot, consume beta, move the dot. The alpha or beta or both can be a non-terminus. Then the dot is moved from alpha to beta or in front of beta or after the beta only if we have seen all the productions of alpha and beta, right? It is a bit confusing, but we shall make it quite simpler when we implement it. This is concept, but the implementation is quite simpler. Okay. Uh, and the item is the rightmost dot. When the dot reaches the extreme right, we call it as reduce item. Else, it is just a shift item, but it is not 100% correct. We have small variation. Dotted example, have a look at this. We'll start something like this. If we have a production, A produces X, Y, Z, and we are not bothered X or Y or Z is terminals or non-terminals. If it is terminal, just X, Y, Z. It is non-terminals, all the productions of them, right? X, Y, Z. Okay. So usually we start from the dot at the extreme left of the production. After consuming these symbols, the dot is moved next. You can see in the second one, before the dot was before X. In the second one, dot is moved next. It indicates that we have already parcel X, and so that's the reason dot is moved next. Next, we have considered Y. That's the reason dot is moved next. Until this should be done until when? Until the dot reaches the extreme right. Okay. So these are shift items. When the dot reaches the extreme right, it is a reduce. Okay. Uh, and when there is a production epsilon production, A produces epsilon, then we're going to write it like A produces dot like this. Okay. Yeah. Uh, okay. This dot indicates how much of the production we have already seen and when to stop, both the things. Okay. Observe. This is the takeaway. This is the learning. Please understand this. How this is implemented in your while solving the problem. We start with a dot in front of the augmented start state, which we have created in the step one. Here, as I told, first and followed, we don't use the augmented start state, but we will use it in construction of LR of 0 items. Okay, and if there is a dot in front of an item, please observe this is how the recursive building of your LR of 0 items will happen. If there is a dot in front of a non-terminal, then all productions of that non-terminal should be included with the dot notation in the same state, right? If there is a dot in front of a non-terminal, if it is there in front of a terminal, nothing to worry. We consume the symbol and move to the next state, right? And if there is a dot in front of a non-terminal, we should include all its productions with the dotted notation in the same state. That's what is the thing. Move the dot after consuming the symbol and move to the next state. So after consuming a symbol, you cannot remain in the same state. We will go from one state to the other. What are the states? We're going to see that, right? Stop when the dot reaches the extreme right of the production, right? So, and when the transition is on a terminal, it's a shift action. When the transition is on a non-terminal, we call it as go to. When the dot reaches the extreme right, it is reduce. And when the dot reaches the extreme right of the augmented start state, we call it as an accept. We shall see that this is the so first state. Actually, how to start drawing this is I have a complete picture. Forget about the second, third, fourth, fifth productions. So it starts with S dash produces dot S. And according to our previous rule, if there is a dot in front of a non-terminal, we should include all its productions with the dotted notation. So for that reason, we get S produces dot open parenthesis L close parenthesis S produces dot X, right? So these two things we got. One second. This I read. The reason is means we get only the S productions, right? Okay, yeah. S produce. We started with augmented start state. S dash produces dot S produces dot open parenthesis L close parenthesis S produces dot X, and you see that in the second production dot is in front of a terminal, so no need to include L productions. In the third production, S is also dot is there in front of a terminal, so no need to include the productions, right? Fine. Now the next move from this state we are calling it as I0. From I0, first move I can make it is consuming yes. When I consume yes, then I'm going to reach a state H dash produces S dot. Now the dot has reached the extreme right, so it should be a reduce, but it is not a reduce now, but it is an accept state because we have got the dot to the extreme right for the start state, and that is a point where we need to stop parsing. So for that reason it is called as a accept state. When the dot reaches the extreme right for the argumented start state, it is called as a accept state. Fine. Okay, the next move is possible on open parenthesis. Now observe the thing, we are reaching a new state called I2, wherein if I move the dot for the second production by consuming open parenthesis, we will reach this. S produces open parenthesis dot L close parenthesis. As there is a dot in front of L, I should include all L productions. What are the L productions? L produces dot S, L produces dot L comma S. So there is again a dot in front of S, so I should include all the S productions. So we get S produces dot L close parenthesis, S produces dot X. Observe that only rule is that if there is a dot in front of a non-terminal, all its production should be included with the dotted notation in the same state. Okay. Now one more production is left out in I0. So I0 had three productions. One got completed in state I1. One more move we made it on to I2. One more we are making it on to I3. I3 S produces X dot. Dot has reached the extreme right. And here when the dot has reached the extreme right, for all other productions except the argument state, it is a reduce action. It is a reduce action that has happened. Okay. Okay, now before going to the next, you can see in this I1 dot has reached the extreme right, no further movements. In I3 dot has reached the extreme right, no further movements, and we have seen all possible movements from I0. Now the only one state that is still can have the movement is I2. So for that reason, what we're going to do, we'll see the next move from I2, that is on L. We can move on L. Observe on L. You observe here, S produces, this first production will become S produces open parenthesis L close parenthesis, L dot close parenthesis. This means we'll be having one more move on close parenthesis. Similarly, see the third production, that is having L produces dot L comma S. So here the dot on L, here the dot can move from beginning of the production to L dot comma S. So that will be our next state, that is state 4, wherein in the first production we got S produces open parenthesis L dot close parenthesis. The next, that is L produces L comma S, will go to become L produces L dot comma S, right? The next production is possible on S. So S, we have L produces S dot, and I5 is also closed now. There is no further movement because the dot has reached the extreme right. And if there is an open parenthesis, what will happen again? You go into this production, S produces open parenthesis dot L close parenthesis. Again, we have a dot in front of a L, so we should include all L productions. Again, we're going to get a S dot in front of S, so we should include all the S productions. That means this becomes a self-flow. We are reaching the same setup, same combination. When you have when you get an open parenthesis, that is for this production, S produces dot open parenthesis L close parenthesis will going to be, if we consume open parenthesis, will reach the same state. Similarly, if we have consume the X, again we're going to get the same state. S produces X dot, that is nothing but your I, correct? Oh, okay, now we have seen all possible moves, 1, 2, 3, 4 moves from I2. And I5 is already closed, dot has reached the extreme end. Now which are closed? 1 is closed, 3 is closed, 5 is closed. But only one who is open is 4. We can have the movement on 4. On the 4, the first movement is possible on close parenthesis. So we get S produces open parenthesis, L close parenthesis, dot. And 6, we are reaching the state 6. 6 is closed. Right. Next state, we have a movement on comma. So we get L produces L comma dot S. Now there is a dot in front of S. We should include all S productions. So we have included S produces dot open parenthesis L close parenthesis, S produces dot S. Now there is a next move only from 7. From 7 we have a move on S. We get L produces L comma S dot closed, right? But still from 7 we do have two movements. One is on open parenthesis. When it is when I consume open parenthesis, we'll go to state 2 again. It is because we get S produces open parenthesis dot L close parenthesis. And on X, you can guess we are going to I. So this is what we call it as LR of 0 item set. So we build the parts tree. Your parts table is nothing but tabular representation of your LR of 0 items. Tabular representation of LR of 0 items. Have a look quickly. You need your first and follow set of symbols. You need your LR of 0 item set, and you need your productions. So as to fill the what you call parts table. And this is how we do that. First, observe now. First, I need to tell about the parse table of bottom-up parser. In top-down parser, parse table used to have all the non-terminals on columns and non-terminals on rows, correct? No? And we used to write the matching productions. But now in bottom-up parser, it's totally a different thing. Parse table will going to contain terminals. You can see open parenthesis, close parenthesis, comma, X, all terminals. We have dollar also, and also we have non-terminals. Terminals and non-terminals are written on column. And the part which is about terminals is called as actions. Means in this part you can have 4 actions. What are they? Shift, reduce, accept, error. 4 actions can be there in this action part. Go to is on non-terminals, and go tos will going to be taken while parsing when you have did the reduction. When you have did a reduction and replaced a handle by a non-terminal, then we go for a go to. Okay, and then what is your rows? Your rows is the states which you have got from your LR of 0 items. See there we had the states from 0 to 8. So here also we have the states from 0 to 8. I will observe and understand properly. Whatever is the moments that is happening in your what you call LR of 0 items, the same will be written in your what you call parse table, right? Where and when is what is the thing that need to be known. And here one thing I'll tell you, when a shift is happening from one state to the other by consuming a terminal, we call it as a shift action, correct? Shift action. And when the dot reaches the extreme right, it is a reduce action, right? And all reduce action should be written in follow. All the reduce action should be written in follow, and all the shift action no need to be written in first. Yes, that is also correct. But it is very clearly evident from the LR of 0 item set that on which symbol the shift is happening. Very simple. And augmented start state, the dot reaches the extreme right, will going to represent an accept action, and that will be written in dollar, right? Because accept can be announced when we have got the start state, and we should have dollar on the input, right? and the go to will happen just immediately after the reduction. That we'll see. But as of now, how to think? Take the first row. First row is first state. Second row is second state, right? So that's the reason we have given the same notation. State 0. 0, I0. See the outgoing lines. We have 1, 2, 3 outgoing lines from I0, correct? 1, 2, 3 outgoing lines. First line outgoing line is on S. So in S, which is go to, it is not a shift action or a reduce action. So what we're going to get is from 0 on S, you are going to which state? 1, right? This is go to, no actions, right? And on opening parenthesis, you will be shifting and going to 2, correct? No? So from I0 on opening parenthesis, you are shifting the symbol, open parenthesis, and going to 2, state 2. So for on opening parenthesis, we are writing it as S2, means shift open parenthesis and go to 2. Similarly, on X from 0, we are going to shift X and go to 3. So that's why we are writing it as S3. Got the idea? So 0 is completed. Now we shall go to 1, right? State 1. In state 1, dot has reached the extreme right for I1, means start state, correct? So as I told, this will be an except on dot, right? This is the only except state. You will not have multiple except states in your bottom of parsing table. So we completed 0, we completed 1. Next on row 2 is having, that is your state 2 is having 1, 2, 3 outgoing lines. 3 outgoing lines. One is on L, so which is a go to. So from state 2 on L, we are going to state 4. And next one is on S, which is also a go to. We are going to 5. And we have two shift actions here. One is on opening parenthesis back to state I2, and one is on X, which is from 2 to 3. So on opening parenthesis, we are shifting and going to 2, and on X, we are going to state, right? And from state 3, what we have? The reduce action. Please observe this. X has reached the dot has reached the extreme right in this one by consuming X. But the production, who is producing it? S is producing. So as to write the reduce actions, we should take the follow of S. What is follow of S? Dollar closing parenthesis comma. See state 3, dollar closing parenthesis comma. We are writing R2. What is this R2? We are not going to stage 2, but it is reduce action based on the grammar rule number 2. So we gave the numbering for this reason only, to as to write it onto the parts table. So on closing parenthesis comma and dollar, we are reducing based on the second production, that is on S produces X. So all the reduce actions will be done like this way. Now state 4, two outgoing lines on closing parenthesis as well as on comma. Have a look. On closing parenthesis, we are shifting it to 6. On comma, we are shifting it to 7. Right? And again, in 5, dot has reached the extreme end. So we are reducing. We are using the follow of L. Follow of L is closing parenthesis and comma. We are reaching the state, means we are reducing based on the rule. L produces S. Right? Okay. Next is again state 6 is also a reduce, where the dot has reached the extreme right. So here we are reaching, 6 is dot has reached the extreme right. We are using the follow up yes on dollar closing parenthesis and comma. So we are writing reduce, 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 and it is based on rule number 1. Similarly, in 7, you can see from say state 7, we have two outgoing lines S. Three outgoing lines S, so open parenthesis and X. S is a go to, so we are writing on S, we are going to state 8, but on opening parenthesis, we are going to 2, and on X, we are going to 3, right? And finally, the last state I8, which is a reduce action because the dot average is extreme right. It is reduced based on the rule number 4 or the production number 4 on the follow-up. Yes, so here you should have got one more. So, yeah, on L. So the follow of L is closing parenthesis and comma. So they're reducing it based on the rule number 4. That is L produces L comma X. This is your first step. You got shifts, you got reduces, the action part, and you got except. Then you match where is error. All blanks in the parts table is errors. And the go-tos, when we reduce, where to go is indicated by your go-tos. Next class, whenever it is possible, I stop here. We shall see the parsing, right? How the parsing should be done by using the parse table. That's the topic next week. So at least you should be capable of constructing the parse table. One more class in half an hour, we shall complete this parsing. And in the notes which I have sent, I have solved a lot many number of problems. You can refer that, solve it. If you have queries, you can contact me. So this completes, actually one more class will be there. This completes your uh, fourth module, which was left out after before your lockdown was happened. So this is your bottom class. Fine. Thank you.